Hi everyone, thanks for joining in again. We're back at our training wall here. Today we're going to be going through our practice meter test wall. A couple things you're going to need when you get started is a meter, of course, but we always want to start with, this is for review purposes only and not intended as training. It is to help you guys review on how we get through our wall. So the first thing we're going to talk about is kind of the basics. We're going to talk about meters. One, we want a meter that's at least a Cat. You'll usually see it at the very bottom here. We'll say Cat 3 600 volts. That's our bare minimum. If you want to get the nicer ones that have Cat 4 600 volts, that's even better. That's more for outdoor use. But for us, we live in that Cat 3 600 volt range. So any meter like that, something with a clamp meter, something that's minimum max, and that is available to do the hold and some of the other buttons that are on there. Okay, so our wall is set up for all kinds of different testing. This wall is a 120 wall, so we've already checked out our key and taken off our lockout tag out. So we're going to start with kind of the easiest one out of the bunch, okay? So we're going to take our meter, we're going to put it up to something, and we're going to do a hold. Now, if you look right here on mine, there's a hold button on the side. That kind of gets us in the right realm. So we're going to go ahead and turn it on to amperage. Amperage on this one, we can do either AC or DC. So that's the A with for AC power is the wave. And then if you're doing DC, it's the line with the dots on the bottom. Mine happens to say AC on it. If you want to flip it, you just hit the select button. So we're going to come over here and we're going to do a hold test. We want to see what kind of amperage the system is running right now. We're going to go ahead and turn it on. We're going to hit our select light so we can see. We've got our light up top and we've got our screen here showing 0 amps. But if we couldn't see that, let's say that we flipped on a couple lights here, we're getting roughly, it's half a watt really is what it is. So because maybe I've got this stuck into a panel where I can't see it, I'm going to go ahead and hit the hold button. I can go ahead and unclamp it from my item, and you can see here, it allows you to be able to see it in the terminology that you can see it's 0.5. Now, as soon as I hit that button again, it goes back to 0 and resets itself. Our next test we're going to try to do is we're going to test our voltage here. So on ours, we have the ability to be AC or DC voltage. And we just hit our select button and go back and forth. Yours may actually be on the dial. Doesn't really matter. We're going to go ahead and clip it off to something. We can use all kinds of different things that we want. This one has a strap on it, so I'm just going to strap it off real quick with the magnet. Make sure you're not strapping these in a place that can be dangerous. But I'm just going to go ahead and put it on there. I have my proofing unit here. The proofing unit I'm going to set to AC first. So this simulates 220 power, okay? Or 240 power, sorry. We're going to go ahead and make sure our leads are in the right position. We're going to see the green there, and it says we have 247 volts. So that's kind of where we're at right there. We also want to do a test on 120. So we'll either take the caps off, or on mine I just roll them back. So we can test 120 power. We're going to come over here, we're going to stick our lead in here and in the neutral position. And we're going to you got to kind of dig around for it. There we go. So we get the audible beep out of our meter. We're getting 119 volts, which is pretty close. We're running on a two-way system here. So we're pretty good right there, 119 volts. We're good to go. So we know that our 120 system's doing good. We want to make sure we roll back out or put our caps back on after doing that test. Once you're done with that test, you move over to DC power. DC power, we go ahead and we flip up. Let me flip off some of these lights here, guys. We're going to go ahead and have our DC. We flip it into DC power. Now, yours may be different. You may have to roll the dial. Mine, I just hit select. We'll see the DC on there. We want to check and make sure this is working properly and our leads are installed properly. We're going to go ahead. It's going to give us 245 volts DC. I'm also going to make sure my leads are in the right position. So if I flip them so the red is now where the black's supposed to be and the black is supposed to be in the red, when I push on there, it's going to be negative 245 volts. Then I can come over here and test my battery. We have a little 1 volt battery over here, and it gives us 1.3 volts. That's where we want to see it testing on a AA battery. It's just showing what you can test there. Big voltages down to little voltages, totally fine. And to see that there is a difference in DC, we can mix that up, okay? So once we've done that, we're going to do our next test. It's going to be a Hertz test. So we're going to come back up here. We're going to go on to Hertz. That's the HD percent. That's only for AC, by the way. We're going to clip that on, and we're going to use our clamp meter for this one. So we put it on the HZ position. We're going to go ahead and clip it onto our black wire, and we get 60. It's doing 59 or 60, right where we want to be. We want to be within 59.5 and 60.5 is kind of where we want to be to have real stable power. We have good stable power here. So we're at 59.99, 59.7, you know, somewhere in that area right there, 60 kind of bouncing around in there. And when we're doing this, there are 2 little lines on our items, and that means it's most accurate if we're trying to get super accurate readings right where those little lines are. There's little indentions. You can see both those there. That's where it's going to be right in between, okay? So once we've done that, now remember, if we're trying to take amperage readings and I go over both of them, so if I want to do amperage here, it will cross each other out if I go over the white and the black. So this might be an area where if you're trying to get amperage, you might want to use one of these guys, this little amperage block. It allows you to be able to only pull one side out of there, just the hot. And it also does 10 times, which is nice if you need it. So that we could use too. So we're going to jump back over here, clamp it onto our meter here, just make sure everything's going. Still showing I'm running the one little guy here. We're 0.30 watts or amps. So we're going to do a test here to test a fuse and to test for a short, okay? So the first one, we're going to go ahead and just put it on our meter here. We're going to tag out our lines. You'll hear the audible beep. This is just testing for continuity. We're not really worried about, you know, resistance just yet. We're just testing for continuity. We're going to go ahead, clamp us back up just so we have something to clamp to. I'm going to come over here to our 2. We're going to test ahead of time. Coming down to about 0.5. Anything below 0.5 we feel pretty good about, and just a standard continuity test. So we're going to test these 2 fuses. We're going to see which one's bad. I'm going to put my lead on one side, lead on the other, and it says this fuse is good, okay? Because it's zeroed all the way out. It goes all the way down to 0. Remember, OL is overload. So let's test this next one and see if this guy's good. And we get no continuity between the 2. So this fuse is bad. So kind of to let you know, if we wanted to find out exactly how efficient the fuse was, we could go ahead and hit our select button and get where we're actually doing our ohms test. We're really trying to find out if there's any, we can do this a lot of times in circuits. You'd want to find out if there's any bleeding power anywhere, and that would be kind of where you're at. So you'll hit noise, and then we're on our ohms test. We can go ahead and test this fuse to see if there's any resistance in the fuse. It's going to go right now. There's just barely any. It's actually 0.6. So the fuse is in really good shape. We're not seeing anything there. They can lie to you periodically. Next, we are going to go ahead and do a amperage test, which we kind of talked about here. We're going to go ahead and roll the amperage over. We're going to come here where we go to amps, AC, and we're just going to turn on the lights and see that we're going to write it down. Make sure we're getting all the same settings here. We're not going to do any selection or anything else. We're just seeing that our amperage is working properly. and we're testing for that circuit. Now, this is a 15 amp circuit that we've got it hooked to. So we're gonna go ahead and flip on. So if we turn on all the things, maybe we've got a customer that's popping breakers, things like that, wants to know why. So we're gonna come over here, and we see that we've got 0.5 amps, definitely below the 20 amps or 15 amps we'd need to trip the circuit. So we're good to go there. All right, next, we're gonna do a minimum max type situation. This is a surge feature, meaning that I have an air conditioner or something I'm trying to turn on, and I want to get it set up properly. This is where the trick happens. You have to be able to set up your system. So we're going to go ahead to amperage, and then we're going to hit our range button. And right now, we have 0.54. We're going to go ahead and turn these guys off, leave on the GFI. So the GFI is working, and we want to hit range and get it off of auto range and all the way over. So now we have 0.0. So we can at least get 100 amps caught before that trips, or basically 900 amps, you know, whatever you want to call it. Then I'm going to go ahead and hit the max button. I'm going to come over here to max. I'm going to go ahead and do two things. This will tell me we have to have a motor. So we're using this, this grinder here as our surge item. So anytime a motor kicks on, it'll have a really big ramp up, and then it will stabilize. You can't catch it with your eyes. You can catch it with the min-max feature. So we're going to go ahead and turn that guy on. It's going to be a little noisy here. So we set there. It clocked in at 14.5 amps. Now what we're going to do here is we know that it's already held and everything. We could actually hit the hold button if we needed to. But for the max, we're good to go. We're going to go ahead and turn that off and just turn it on one more time. Brings it down to 0. Now we're going to bring the amps up and see how they hold. I'm assuming it's going to be right around 6 amps that it's going to take to get it thing to just run through the items, and then we can check that on our item and make sure that's good. So we're going to go ahead. Okay. So we saw it ramp up real quick, couldn't really catch it. Knowing that that's where we had it before, it ramped up way high. So if we had a circuit that we knew we were surging over, it's surging about 16 amps, but popping right off. That may be something where an air conditioner may be doing 160 amps. And we want to make sure that we can put that on our backup system. Now when it's running though, we caught it at 4.8. It really maxed out about 6 amps while it was running. And now we go ahead and I hit the hold button, and that allows me to be able to see that work properly. Okay guys, so that allows us to see that where we're at, it's well within its rating, right about 5 amps is what it's rated to, is what it should be doing. And the surge wasn't so bad that we weren't seeing 30 amps or something like that. 2 or 3 times up is where you'll see it. On air conditioners, it will tell you where your LRA is, locked rotor amps. And we don't want to see something jump over. So I've been to houses where I'm sitting there, I'm testing the air conditioner, and the air conditioner has an LRA of 100 amps, and it's doing 130 on max, meaning that air conditioner is going bad, and that's why we're tripping breakers. So that would definitely be, that particular one was tripping a main breaker on a 125 amp panel, and it was tripping it over and over and over again, and we were trying to tell them it's definitely a problem with your air conditioner, and we're able to kind of trace that out. So that's what that feature is for. Now let's get into so some of the other features we're going to need to know. So this is just how to use your tester. We have one more thing we want to be able to do, which is test for a short. Now this is our testing wall. We're going to sit here. We have our wires here that are sticking out, and we know that this circuit is tripping. So we want to see, is there continuity between our hots, between our grounds and our neutral, or any variation of there. Now, our testing wall allows us to be able to switch those up. So if you've taken the test, it won't be the same way the next time you take the test if you don't pass the first time. So we're going to go ahead again. We're going to come over here to our continuity test. We're going to go ahead and ring them out. We're going to come over here to our lines here. Let me see if I can get some light here going. Actually, that's a little bright. I'm going to come over here and I'm going to hook right off the bat. I'm going to go black to ground, black to white, and then black to red. I get continuity through there. So I know that one, either my black or my red is causing the problem. So we're gonna go here again. We're gonna come in here. I'm gonna go red to ground, red to neutral, neutral to hot here. We know that we're not getting anything unless we're touching the two, the red and the black, meaning that our short is on the red and the black. Can we get all of those wires touching? Yes, if you drive a ground rod through all three of them, you will see power, either power or you'll actually see continuity through all of them. But this particular one, we've got a Wago on there and we've got the red and the black tied together and not the neutrals. So this one would have been an instant trip. It's a direct fault. So here, and it tests out, which means we've got a shorted out line where somewhere on the ground or somewhere in here, the two hots are touching together. This would trip a breaker instantly. And that's how we'd find which one it was. We'd be going along maybe through the breakers, testing hot to neutral, and see where that happened, or hot to ground, and see, once we get all the way through, test to ground also, and then red to ground also, and then hot to hot, and see if I get continuity. If I get continuity, a lot of times that's a sign that I've blown a circuit there. So, as I said, that won't be when you test it. You won't get red and black, or maybe you will, just mattering on the kind of the luck of the draw. So guys, this is our first part of our video on this. We're going to be going into our next part. We'll be using a circuit finder, using a voltage sniffer, a voltage detector, and a plug finder. So, or a plug, not a plug finder, but a plug tester to see whether you've got mixed up grounds, neutrals, things like that, and test GFIs. So guys, I hope you enjoyed this video. Remember, they are for review purposes only. Please like and subscribe, hit us up, and then watch our next video on how to do the next step. Kind of get the next, things as you go through your testing purposes. Get signed up. Here it makes you money if you pass things off. You get a little patch on your arm. It's all good to go. But definitely, when you go through here, just watch those all. It's really simple, guys. We're not trying to trick you up. We're trying to make sure you can do all these things so that we can help you progress. So as always, guys, have a great day, and we'll talk to you later.